Welcome to Algebra 2. Today we've got section 7.3, multiplying and dividing rational expressions. All right, so a little bit of a background on what rational expressions look like. They're basically just fractions, and we've practiced graphing rational functions. Well, expressions are like rational functions, except they don't have they're not a part of an equation. So it's not y equals a fraction, it's just a fraction with x terms in it. So you can see a domain of a rational expression. It's excluding certain x values that would make the denominator 0. Those are our vertical asymptotes or any holes in the graph that may have occurred. How do we know when we're simplified? Simplifying will be a big task of today. It's when we no longer have any common factors between the numerator and denominator. In other words, we've simplified the fraction as much as possible. Okay, and then in my own words here, I said since these are essentially big fractions with x terms in them, remember that we can only cancel out factors, not terms. Factors are multiplied, terms are added. And since a fraction means division, we can only cancel out factors that are multiplied together, not terms that are added up. Division, which is what fractions mean, only undo the multiplication. So if we see something like 5x minus 7 over 3x plus 2, I cannot cancel the x's out of that. Okay, those are parts of terms, not factors, whereas if I had 5 times x minus 7 over 3 times x minus 7, now that those factors are multiplied into the numerator and denominator, then the division can cancel out that multiplication. Okay, so here I've just shown you again how to simplify. If something's multiplied into numerator and denominator, we can cancel that. And then examples, you can see that with numbers and with expressions as well there. Now when I multiply two fractions together, I'm going across the top and across the bottom and multiplying those. Okay, so there you can see the property illustrated, and you can see it done with some terms there as well. So I say that multiplying and dividing, I call these trains, because when we factor, we kind of set up these little groupings in parentheses most of the time, and then we kind of multiply together, we hook up all those train cars and see what cancels. And then when we get into adding and subtracting, those are going to be accordions, and I'll explain to that when we get to 7.4. For dividing, just remember that when we divide two fractions, it's the same thing as multiplication, except we are multiplying by the reciprocal. Okay, so you can see we've got an example of that. All right, so one of my auxiliary goals, I guess you could call it, about today's lesson is that we revisit a lot of the factoring techniques that we have spent months away from. So for number 4, in order to simplify this expression, notice we don't have to multiply anything, we just need to factor and see what cancels out. So for number 4, the factoring technique, if you feel like you remember this, please, whenever we get to a new slide, pause the video and see what you remember, and then see if you know how to do it on your own. And then you can always, load the video, start playing the video after that to see the correct work done. So that's a good way to practice in the notes as well. For number 4, what I see in the numerator, I can take a GCF of x squared out, and I'll be left with 7x minus 1. And then the denominator, that's already just multiplication. It's 2 times x times x times x. Now, they're kind of tough to see because they're not part of parentheses, and we're so used to seeing factors that way. But in the numerator, it's really x times the quantity 7x minus 1. And in my denominator, it's 2 times x times x times x. Well, those exponents are just showing things that are multiplied together over and over again by themselves, so I am able to cancel out x times x in both the numerator and denominator. Those are two sets of factors that do cancel, and my simplified rational expression is 7x minus 1 over 2x. And again, that's where we stop. We cannot cancel out the x's there because they're no longer factors in the top. Those are terms. Okay, for number 8, here, this factoring technique, it's just a basic trinomial in the numerator. I want to factor that up again, establish those train cars. And we're pretty lucky that we have a lead coefficient of 1 out in front, because that means our factors are just going to be x times x to FOIL together and make that x squared. And I want them to multiply to be 12, add up to -7. That's a -3, -4 for those magic numbers. And in the denominator, you may look at that and think, no way am I able to cancel or factor that out. This is a difference of perfect cubes. It's x cubed minus 3 cubed. And let's just revisit that rule. I know that the first factor is going to be that same expression without the cubes, so just x minus 3. And then the second part of it, let's just think about what it would have to do to FOIL back to make x cubed minus 27. I would have to do first times first, x times something to make x cubed. That has to be x squared. Then last times last, negative 3 times something has to make negative 27. That must be a positive 9. All right. Now in the middle, we are just taking the two terms from our front factor, the 3 and the x, and multiplying those together. And this sign has to be opposite what we had in our front factor. Since we want everything in the middle to cancel out, I need positives and negatives to cancel each other out in the middle. So plus 3x is in the middle there. That is factored completely. We cannot do anything with the x squared plus 3x plus 9. That is unfactorable. But we do see that we were able to set up a factor of x minus 3 that did cancel. Final answer, x minus 4 over x squared plus 3x plus 9. And lastly, for number 12, here you can see our numerator. It's another cubic function, but this time we have 4 terms. Well, our only hope at factoring this is by grouping. So we'll set up our groups, see what we can do as far as a GCF out of each group. I'm able to take a 3x squared out of the first group, and that leaves behind an x minus 1. And I'm able to take out a positive 7 from the second group, and I want to leave behind the same set of parentheses. In this case I do. It's x minus 1. Okay, and in my denominator, well, let's finish the numerator first. We're kind of on a roll with that. I want to undistribute this GCF. It's a factor they have in common now, x minus 1. So I'm going to undistribute that. And what's left over? It's just what's outside parentheses, 3x squared plus 7. So there I've got the numerator all factored out using grouping. In the denominator, I can take a GCF of 3 out, and I'm left with 9x to the 4th minus 49. And it may look like it's unfactorable, but this is actually a difference of perfect squares. And the 9 and the 49 plus that even power on x, those are a dead giveaway that we should be able to factor this using difference of squares. I've got a 3 out front. I've got 3x squared plus 7 and 3x squared minus 7. I just want to make sure that those two factors are conjugates. They have the exact same terms, it just one is a plus 7, the other is a minus 7. Okay, let's clean it up. We do have a factor, 3x squared plus 7, that does cancel. So my final answer is x minus 1 over 3 times 3x squared minus 7. And we don't have to distribute back in. This is our answer. We are set. Alrighty. Now for example 2, here we're going to practice some multiplication problems. And you can see number 12, all of our factors are already established. You can see everything in all the numerators and denominators, it's all multiplication. But because we don't have any parentheses, we see that multiplication as shown as exponents on variables with some coefficients out there. It is just straightforward multiplication, so I'm going to go across the top and across the bottom. I get 48x to the, I got 5 x's multiplied together, then I multiply in 2 more x's that are multiplied together. That means I add the exponents. I get x to the 7th power. And that would mean I have y to the 4th. In my denominator, I've got 6, x to the 3rd, and y to the 6th power. Okay, remember, those are all factors. They're all multiplied together. So 48 divided by 6, that simplifies as a fraction to 8 over 1. X to the 7th over x to the 3rd, that simplifies to x to the 4th in the numerator. And y to the 4th over y to the 6th, that simplifies to just a y squared in the denominator. There is our simplified answer. Okay, and if we wanted to see all of the cancellations, we wanted to cross off all those things that canceled, we could just simply write out 48 is 6 times 8. 7 x's multiplied together, 4 y's multiplied together, and cancel them all out, what we'd be left with is 8 in the numerator, 4 x's in the numerator, and 2 y's in the denominator, all multiplied together. So there's our answer. A more common problem would be one like 16, where we have some more obvious factoring that needs to take place. It's really tempting to look at x squared minus 4x and say, oh, that's x plus 2x minus 2. But it is not a difference of perfect squares because of that x. So all I can do to factor that is take a GCF of x out. Okay, now in the denominator, x minus 1 is a linear factor. I cannot factor that any further. X squared plus 3x minus 4, well, that's x plus 4, x minus 1. Factor that using magic numbers. And then 2 times x, those are already factors. All right, so we got all of our train cars set. Let's hook them up and see what cancels out. So I've got x times x minus 4 times x plus 4 times x minus 1. There's our numerator train. Denominator is 2 times x minus 1. And I'm just going to move that 2x out front. Usually when we have loose factors that are not a binomial factor, we usually write those out front just to keep things organized. All right, so what cancels out? What simplifies? Well, I have a factor of just x multiplied into the numerator and denominator. And I've got a factor of x minus 1. So those all cancel out. Final answer, x minus 4 times x plus 4 all over 2. It's considered simplified when we have no common factors between numerator and denominator. All right, for our next slide here, we're going to use division, and we just need to be very careful that when we find a division problem that we remember to use the reciprocal. Okay, so for the first problem, I've got 2xyz over x to the third z to the third times, let's show our reciprocal, 2x squared z squared over 6y to the fourth. Okay, now let's go across the top, across the bottom. 2 times 2 is 4. I will have x to the third, y to the first, and z to the third. Across the denominator, I've got 6, x to the third, y to the fourth, z to the third. All right, and then we simplify. X to the third, z to the third, z to the third. Those are multiplied into both numerator and denominator. They cancel out perfectly. I'm left with 2 over, and then that y over y to the fourth, one of those y's is going to cancel out. I'm left with 3y to the third. So I simplified 4 over 6 into 2 over 3. And then with the variables, we're just left with a y to the third in the denominator. All right, factoring frenzy here in number 34. It is division, so I do want to remember that reciprocal. A lot of students will say that nothing cancels because they forget to use the reciprocal. Don't be that student. All right, so first, if I factor this trinomial, I get x minus 8, x plus 5. We should be pretty good at doing basic magic number factoring by now. And I get x plus 8, x plus 5. When I factor that second numerator, I get x, well, let's see, what would that be? Minus 2, x plus 10. And I get x plus 2, x plus 10. Now let's show that we can hook up those trains using the reciprocal. So I've got x minus 8 times x plus 5 times, when I do the reciprocal, x plus 2, x plus 10. Okay, some people choose to show like a little arrow or something as a reminder. You can do that if you want. Okay, then I want the first denominator, x minus 2 times x plus 10. And then for my reciprocal, x plus 8, x plus 5. All right, what cancels out? My x plus 5 factors cancel out, and my x plus 10 factors cancel out. So I'm left with x minus 8 times x plus 2 over x minus 2 times x plus 8. And those factors do not match. Even though they're very similar, I cannot get those to cancel out. Now, another thing that students will often do wrong is they'll take the reciprocal of the wrong fraction. Division has an order. If I do 1 divided by 3, that's not the same thing as 3 divided by 1, so it's always the second fraction that we take the reciprocal of. The order matters. Second one only. Our final example for today has both operations in one problem, and just think, in general, our order of operations says that when we're doing multiplication and division, we do that in one step from left to right. So we're just going to want to make sure that we're using the reciprocal when we need to, and that we've got everything factored and set to cancel out. So the first little expression that I have here, x cubed plus 8, if I were to factor that out, hey, it's x cubed plus 2 cubed. It's a sum of perfect cubes. That's x plus 2 times x squared minus 2x plus 4. And just because we're dealing with fractions, I'm going to write that as being over 1, just so I know what's in the numerator, I know what's in the denominator. Okay, I'm going to multiply that by this next fraction, which x minus 2 I cannot factor out at all. And the denominator, x squared minus 2x plus 4. What multiplies to be 4 and adds up to negative 2? And hopefully we think about that for a while and say, well, nothing. That is not factorable. So I'm just going to leave that as is. But we should not be super alarmed by that, because look at what we got when we did our perfect cubes earlier. We got the same thing. That huge trinomial factor, it looks like it's going to cancel out. Now for our last rational expression up here, I'm dividing it, so I'm going to use the reciprocal, and I hope it's okay with you if I do that in one step here. Let's get it all factored out. My numerator is a difference of squares, so I got x minus 2, x plus 2. Then my denominator is just a linear factor x minus 6. So I'm just going to group that in parentheses. If I take the reciprocal, that's going to become x minus 6 over x plus 2, x minus 2. And now that I have it all set up, these are all these train cars, if I multiply, they're just going to get hooked up. So all the way across, this can be thought of as one big fraction with all of these being multiplied together across the top and across the bottom. Let's see what cancels out. Well, I've got an x plus 2 in both numerator and denominator. It's multiplied into both. It cancels. I've got that trinomial factor. That cancels. I've got x minus 2 multiplied into the numerator and denominator. That cancels. So my simplified answer is just x minus 6. Again, the majority of that practice is just exploring those factoring techniques that we may not have seen in some time. That does it for section 7.3. Here's a look at your homework assignment for this section.